Okay, so today we're going to look at some tips for balancing equations. Right then, so every single element on the periodic table has its own elemental symbol, and that symbol begins with a capital letter. That's really, really important to note because when you write chemical formulae, you need to start every new element with a capital letter. I'm going to give you an example quickly, very simple one. We've got a molecule here that consists of one atom of carbon and two atoms of oxygen. The atoms are clearly represented by the circles, which are obviously spherical in real life, but note how each atom can be of a different element. So we've got an atom of the element carbon and we've got two atoms of the element oxygen. So the way this formula should be written, as I'm sure you already know, is C, because we've got one of it, we don't write a number after it, O, and then we write a 2 after the O, which tells us that we have two atoms of the element oxygen. Notice how it's written small and down low. Now, a very common mistake that students will make, just to point out why you should be particular about doing this, is they may write CO2 like that. Now, this here doesn't tell me that I've got one atom of carbon and two atoms of oxygen, because the O, as you've clearly noticed, doesn't start with a capital letter. This tells me I've got two atoms of cobalt. Okay, so that would be something a little bit like this. Cobalt bonded to another cobalt. Okay, so my key point here is be particular about your capitalization of element symbols. Okay, so now what you can see here is I've got that same molecule, carbon dioxide or CO2, but I've got it twice. So in total, what I have is 2 of CO2. So if I was going to count all of the atoms here, what you could see is that this number in front here, so the 2 that is in front of the CO2, to show I've got 2 molecules of the carbon dioxide here. This number in front, if we were going to work out the total number of atoms of each element, we have to times everything in the formula by the number that is in front of it. So here you can see if I times it by 2 times the 1 there, so total carbons I have 2, and then I'm also going to do 2 times the 2 oxygens here, so total oxygens I have 4. Okay, nice simple example there for you. Okay, new molecule here. This is magnesium hydroxide. Now, you may be forgiven for believing the formula for this should be, well, you can see we've got 1 magnesium atom, we have got 2 oxygen atoms, so I'm going to write a 2 there, and we've got 2 hydrogen atoms. But there are certain compound ions, they're called, so certain little collections of atoms within molecules in chemistry called compound ions, and when we have them we have to represent them slightly differently. So we've got some compound ions. Now these are hydroxide, OH, it's actually got a minus charge on it but we won't look at that right now, nitrate, which is NO3 minus, sulfate, which is SO4 2 minus, and carbonate, which is CO3 2 minus. Now, whenever you have one of these in a formula, if you have more than one of them, then they have to go in brackets. So you can see, looking at the compound ions here, the compound ion present in magnesium hydroxide is the hydroxide compound ion, which is, if I just show it with a little colour here, okay, which is the hydroxide ion is this bit of it here. So these things, these atoms, they always have to come together, okay? So we have to write the formula ever so slightly differently. So what I've actually got here, change back to black, what I've actually got here is 1 magnesium and I've got 2 of the hydroxide compound ion. So I put it in brackets and I say that I have 2 of them. Now, the reason we put these in brackets is if a chemist sees OH, they recognise the naming system of hydroxide, whereas if a chemist sees O2H2, they would think it's something else, probably something like a peroxide or hydrogen peroxide. So with the compound ions hydroxide, nitrate, sulfate and carbonate, we have to preserve their formula, and to do that we have to put them in brackets if we have more than one of them. Okay, so a really advanced example here now. We're looking at iron 3 sulfate. So iron 3 sulfate, you can see it's got 2 iron atoms in it here. And again, you would be forgiven for thinking we could have like S3O12 here, but actually the sulfate ion again is a compound ion, so it has to be shown as a collection of atoms in the formula. So here's one sulfate ion, and as you can see it's composed of one sulfur atom and 4 atoms of oxygen, so it's written as SO4. The 2- bit up top here is a charge. It doesn't tell you about how many atoms there are. That's key, okay? So if it's written in the top right here, it doesn't tell you how many atoms there are. Right, so this one here, we've got 2 ions, so I'm going to write Fe2. The reason I can just write a straight 2 after that ion is iron isn't a compound ion, it's an ion of just an element, whereas sulfate here, SO4, is a compound ion. So what I'm going to do is I'm going to say I've got 3 of those sulfate ions overall. So we've got SO4 and then close brackets. I'm going to write a 3 afterwards. Okay, so let's examine this formula. So I can see that there's a 2 written after the iron, so I've got 2 atoms of iron. Okay. All right, now we're going to look at the sulfur. Okay, so overall, you can see hopefully that inside the brackets there is just 1 sulfur. But what you need to do with atoms of elements inside brackets is multiply them by the number on the outside of the bracket. So I've got this 3 on the outside of the bracket. That's effectively 3 times 1. So I've got 3 sulfurs. I've also got this 3 on the outside of the bracket with a 4 oxygens on the inside. So that's 3 4s. So I've actually got 12 oxygens there. So that's how many atoms of each element I have. But as you can see, because the formula contains a compound ion, we need to preserve the compound ion's formula to enable chemists to name it. And then we just multiply it by how many of those that we have. Okay, on the page now you can see that I have 1 molecule of H2O. Okay, there's just 1 of them there. And in terms of the number of atoms, I've got 2 hydrogen atoms and 1 oxygen atom. So I could represent this in an equation as H2O. Okay, now in equations, as you hopefully know already, you can put balancing numbers in front of the equations. They normally in an exam would give you a gap to put the balancing number in. Okay, so at the moment, because there's no number written in front of H2O, I've just got 1 H2O. So in terms of my numbers of atoms, I've got 2 H's and I've got 1 O. Okay, so that's how many atoms of each element I have. Now, if I just duplicate this quickly here, there we go. Okay, so now you can see that I've got 2 molecules of the H2O, 2 of them here. Okay, so what I can do is I can put a 2 in front of this. Okay, so I put a 2 in front of its chemical formula. Notice how that number is big, okay, and it goes in front of the chemical formula. So now what I need to do is, if I'm considering how many atoms of each element I have, I need to multiply everything in the chemical formula by the number in front of the chemical formula. So we've got here hydrogens, we've got 2 in the chemical formula, but we've got this 2 in front of it. So I'm going to do the 2 times the 2 hydrogens, which means that now I've got 4 hydrogens. And I'm also going to do the 2 times the 1 oxygens, which means I've now got 2 oxygens. So we call these numbers coefficients, the big numbers that go in front of the chemical formula. Okay, but really all you should think of them as is the balancing number. You've got an equation in front of you that you need to balance. So my first recommendation is that you draw a line directly down the middle of the arrow. Okay, so we're going to do that. And then what we're going to do is we're going to list the symbols for each element, which should be both the same either side of the equation. Okay, so this side we've got iron and chlorine, and this side we've got iron and chlorine. There's no need to include the balancing numbers in this, so I'm just going to write Fe. I've got that element there, and chlorine, I've got that element there. Okay, so I've got iron again, Fe, and I've got chlorine this side of the equation. Okay, what we can see then is if we look at the formulae before we have balanced it. Currently on this side of the equation we have got 1 iron atom, so I'm going to write a 1 there. And currently on this side of the equation I've also got 1 iron atom. Oh, it looks like it's balanced, okay, but let's just continue. So next up, we have got 2 atoms of chlorine this side of the equation. Okay, so we've got 2 here. And then if I look onto the other side over here, you can see I've got 3 atoms of chlorine. So I'm going to write a 3 over here. Okay, so we're going to balance, clearly. What we need is for these numbers that I've written here, so ions, chlorines, I need the ions either side to have the same number, which they already have, but I need the chlorines either side to have the same number, which they currently don't. So my recommendation for this is you look at the numbers of atoms that you have and you try and find a number that both of these numbers will fit into. So we've got a 2 and a 3. So a number that both 2 and 3 will fit into is 6. So 6 is going to be our target for the chlorine. So I'm just going to write here my target is 6. Target is 6. Okay, well, let's have a look what we could do just over here to start with. So my target for all chlorines along this row is 6. Well, I've got 2 here. To turn that 2 into a 6, I would need to times it by 3. So then you need to look back into the equation, look for where the chlorine is. Here's the chlorine. I've currently got 2 of them. And to get the target of 6, I need to times that 2 by 3. So I'm going to write a 3 as the coefficient in this gap here. Okay, so now if I multiply my 3 by my 2, in total, I don't have 2 chlorine atoms anymore. I've got 6. So that's reached my target now. Okay, so now let's have a look on this side of the equation. I've got a number 3. My target is 6. Okay, so I've clearly got to times this number by 2. I need to now look for where the chlorine is in the equation. It's here, but I can only write numbers in front, remember? So I need to get this 3 into a 6. That means I'm going to times it by 2. So I'm going to have to write a 2 just here. Okay, so now if I think about it, I've got 2 times the 3 chlorines. So that means I've got 6 chlorines in total. So that now is complete for chlorine. I've reached my target of 6. But when we put this balancing number over this side in front of the iron chloride, I didn't just times my chlorine by 2, I also times my iron by 2. Okay, so there was 1 in the original formula, and now I've put a 2 in front of it. So now I've actually got 2 irons here. Okay, so now what we need to do is we need to look back over the other side of the equation, and we can see we've only got 1 this side. Okay, so our target must be 2 overall for them to be the same. Okay, so I've got 1 iron this side here. I've got 1 of them. Okay, so I'm going to need to times that by 2 to make it into our target of 2. I'm going to look for the iron on this side of the equation. Here it is. Okay, so I'm going to pop a 2 there. Now I've got 2 times the 1, which gives me 2. And now we can see we've reached our target. So let's summarize. We have now got 2 irons this side and 2 irons this side. 2 times the 1, both are 2, correct. We've now got 3 times the 2, which gives us 6 chlorines this side, and we've got 2 times the 3, which gives us 6 chlorines this side. We've reached the target. This is now a balanced equation. Okay, a slightly different example this time because we're involving a compound ion which, to preserve its formula so chemists can name it, needs to be wrapped in brackets. So you can see that we've got 1 atom of the oxygen within the brackets, but we need to remember to multiply that by 2, and we've got 1 atom of the hydrogen within the brackets, which also needs to be multiplied by 2. This example also highlights a different issue, which is that some elements are duplicated in different formulae. So you can see here that the hydrogen is both present in the magnesium hydroxide, but it's also present in the hydrogen chloride or hydrochloric acid. So we need to make sure that when we're counting the numbers of each atom of each element, that we actually involve duplicates throughout the different formulae in the reactants and in the products. Okay, so let's have a look. We've got 1 magnesium here. We have got 1 oxygen inside the brackets, but it's times by 2 because we've got the 2 on the outside of the brackets. 1 to pay attention to. We have got 1 hydrogen within the brackets and then multiply it by 2, so we've got 2. But then look over here, there's 1 in the HCl, so we've got 3 in total. So 2 here, 1 here. Finally then, here's a chlorine and it's on its own. Let's do the same now for the other side. 1 magnesium, 2 chlorines, 2 hydrogens, and 1 oxygen. Now, you may be forgiven to think about this one here first because, we could fit them both into a 6, but we're not actually going to do that straight away because what we can see is that there's only actually 2 balancing numbers we need to resolve here, okay? There's only 2 gaps, 2 coefficients that we need to put in. So things without balancing numbers in front of them, I want you to start referring to these as key formulae, because the key formulae actually help you balance the entirety of the rest of the equation. So because this doesn't have a balancing gap in front of it, essentially, we don't need to change anything to do with this. So we know that our numbers of chlorines and our numbers of magnesiums are fixed at 2 for the chlorine and 1 for the magnesium. Okay, so it's a key formula. It balances the rest of the equation for us. So we're going to start off looking at the magnesium. It's a 1-to-1, and because there's no balancing number, we can't ever change this. So magnesium's already completed for us. Next up, let's have a look at that chlorine there. We've got 2 this side, but only 1 this side, so a 2 and then a 1. Well, this side is a key formula, so it's balancing it for us. So we've got the 2 there, we've got a 1 there. We need to times this 1 by 2 in order to have it reach the same number as on the other side. So we're going to times this by 2. Let's look for where the chlorine is. It's right here. Okay, so I'm going to cross this out, put 2 here, cross that out, 2 here. Okay, done. But then when I multiplied this by 2, I also multiplied by hydrogen by 2. So we've got to recount everything I've got on the left-hand side now. So we've got 2 hydrogens from this formula here with its coefficient in front of it, and we've got 2 hydrogens from this formula here. So I've now in total got 4 hydrogens this side. Okay, right then. So what we can see now is there's nothing left to balance on this left-hand side, and the hydrogen here is a 4, and the hydrogen this side is a 2. So my new target is a 4. I'm going to think about this number here. I've got a new target of a 4. 2 times 2 equals the 4. So I've got to put 2 in front of wherever the hydrogen is, which is here. There we go. So I've now got 2 times the 2, which gives me 4 hydrogens. Okay, so let's just confirm that we've balanced. I've got 1 magnesium here, 1 magnesium here, correct. I've got 2 oxygens from this, there they are, and I've got 2 of the oxygen if I do the 2 times the 1 here. Oh, needed to put that one in. Done. Okay, next up, hydrogens. We have got 4 this side coming from 2 here. 2 times the 1 gives us 2, and 2 here. And that's correct. And on this side, I've got 2 times the 2, which gives me the 4. This side, I've got 2 times the 1, which gives me the 2 of the chlorine. And this side, I've just got the little 2 after it, which tells me I've got 2 of those. Right, it's now time to do some practice. So I want you to pause the video here, apply the same method to try and balance these 2 equations. Right then, here's the answers. So draw my line, list my elements, aluminium and bromine, both sides. Okay, so this side I've currently got 1 aluminium and 2 bromines. This side I've currently got 1 aluminium and 3 bromines. Common target for the bromines, we've got a 3 and a 2. The number they both fit into is a 6, so my target is a 6. Okay, so let's have a look quickly. To turn this 2 into a 6, I would need to multiply by 3 here. So I've got 3 2's, which gives me my 6. And to turn this 3 into the target of a 6, I would need to multiply by 2. I can only put my 2 here. Now I've got the 2 times the 3, which gives me my 6. I've also got the 2 times the 1 of the aluminium though, which gives me a 2. Now because I've already put my coefficient in here, this is now balanced. So I've now got to look back on this side, so my target is going to be the 2. So I'm just going to pop a 2 into here, and we've acquired that target as well. So this one's now balanced. Okay, let's have a look at the next example then. So this is actually an important reaction. It's how you can extract aluminium from the ore of aluminium, aluminium oxide. There's several ores of aluminium, hematite being the main one. But you can see here that on the right hand side you'll get pure iron, which is extracted from iron oxide using carbon. The name of this method is reduction using carbon, and it's a method of extracting metals that are less reactive than carbon. It's a type of displacement. Anyway, away from the theory, let's just do the balancing right now. So we've got iron, oxygen and carbon on this side, same on the other side. Write them in the same order so you're balancing on the same row. Okay, so I've got 2 irons, 3 oxygens and 1 carbon, 1 iron, 2 oxygens and 1 carbon. Let's have a look to start with. We always try and look at our hardest ones to balance first, because otherwise what you could do is plug numbers in here that then you get stuck with and have to change after you've balanced your more difficult element. So we're going to start off with the oxygen. We've got 2 and a 3. Again, nice target of a 6. Okay, so we've got to times the oxygen over on the left hand side. It's currently a 3. We've got a 3 here. Our target is a 6, so we're going to times this by 2. The oxygen's found within this formula, so I'm going to pop a 2 here. Okay, so we now get a 6. Okay then. Right, next up then, we'll look at the right hand side. We can see it's a 2, so we need to times anything with oxygen by the 3, which is there. Okay, so we're going to times that by the 3. And we've also got a 6, right. But I introduced some other changes here. It's important to note that. When I put this 2 here, I didn't just multiply the oxygen by 2 to get 6, I also multiplied the iron by 2. You can see that I've got 2 irons in the formula, and then a 2 on the outside, so that's 2 times the 2, which gives me 4 irons. Let's have a look on the right hand side as well. I did introduce a change. I put the 3 here in front of the 2 oxygens to get 6 oxygens, but by putting that 3 there, I'm also doing the 3 times the 1 of the carbon, so I've now got 3 carbons. So now what we can do is we can balance for that carbon, because you can see I've already put my number in here. Now just because you've put a number in front, a coefficient, doesn't mean you can't change it in the future if you get stuck, okay? But it's good to use it to work backwards to try and balance for the others first. So I've got my 3 here for the carbon, whereas I've got a 1 this side. So I need to turn that into a 3. I'm going to put a 3 here. 3 times the 1 gives me 3. So we're now balanced for both oxygen and carbon. We've only got one element left to balance for, which is the iron. Now you can see I've got 4 this side. I've already put my coefficient in. So now all I've got to do is make this into a target of a 4 as well. Well, here's the iron, so I'm going to multiply it by 4 to get 4. And you can see that we're now balanced for this equation. Here are some more practice examples for you. Give these a go, pause it, and I will write in the answers. This time I won't explain the methodology. This is time for you to apply it. If you get a bit stuck, just go back, have another look at them, think about the application process. Okay, here are your answers. So for the first one, you need 2 hydrogens, 1 oxygen. Notice how I haven't put a number in front of it, and you will form 2 waters. In this one here, you need 2 sodiums, 2 molecules of water goes to make you 2 sodium hydroxides plus 1 hydrogen. This equation was already balanced. This one here, you need 1 calcium plus 2 hydrochloric acid goes to make 1 calcium chloride plus 1 hydrogen. Okay, well, 1 molecule of hydrogen, sorry. This one here, you've got 2 atoms of aluminium react with 3 molecules of chlorine, Cl2, which will give you 2 molecules of aluminium chloride. Okay, final one, you need 4 atoms of aluminium will react with 3 molecules of oxygen to give you 2 overall molecules of aluminium oxide. I'll give you some more practice coming up on the next slide. Okay, here's another set of examples. Give these a go, and I'll go through the answers in a second. Okay, a little bit easier to wind down. The first 2 were already balanced for you. Hopefully you noticed that. This one here, you need 1 magnesium for 2 nitric acids. That's going to make you 1 molecule of magnesium nitrate and 1 molecule of hydrogen. Okay, next up we have got 2 atoms of sodium will react with 1 molecule of sulfuric acid to form 1 molecule of sodium sulfate and 1 molecule of hydrogen. Okay, so that's all the practice we've got for today. Hopefully this video helped you out, and just keep practicing with this and you will get a lot better.